Welcome back, guys. This is question 5.62 and the statement of this question is the probability that a student at a local high school fails the screening test for scoliosis curvature of the spine is known to be 0.04. Of the next 1875 students at the school who are screened for scoliosis, find the probability that A. fewer than 5 fail the test and B is 8, 9 or 10 fail the test. Okay, so here what is given, let me first write the given data. The probability is given here, which is 0.004, which is here. Okay, similarly the sample size is also given, which is n, and this is 1875. So on the basis of this, what do we have to find out? Here we want to find out a fewer than 5 fail the test means the probability that x is less than 5, which is similar as the probability that x is less than or equal to 4. Okay, and also B, the probability that 8, 9 or 10 fail the test means the probability that x is greater or equal to 8 and less than or equal to 10. Okay, so these are the two probabilities we want to find out. Okay, so now in order to find them out, we have to use what? We can use the binomial distribution as well as the Poisson distribution, but as discussed in the previous section, in these cases where the probability is very low and the sample size is very high, the binomial distribution approximates into the Poisson distribution, and therefore we have to find the average value of it, which is np, lambda equal to np. Let me write here the value of n and p. So the value of n is 1875 multiplied by the p, which is 0.004. Multiplying them together, we will get what? The value of lambda would be 7.5. Okay, so now these are the values we want to find out. This is the value we can find by using the manual method. Okay, the formula for the Poisson distribution is x is equal to k. This is exponential of minus lambda k divided by the k factorial. For them all, we have to use it for 0, 1, 2, 3, 4 and then add them together. Okay, apart from it, what we can use the Poisson CDF table as well. Okay, so let me move to the Poisson CDF table where the value of lambda is 7.5 or the average value 7.5, and we want to find it for the value of x or k, which is less than or equal to 4. So let me find it out. So this is the table. Okay, in order to find it out, let me have the value of lambda, which is what? Which is basically here. Let me go to 7.5. Okay, the value of lambda is 7.5. Okay, this is 7.5, and we want to find out the value of x, which is less than or equal to 4, which is here. So this value is 0.1321. Okay, and that is what? 0.1321. Okay, so that is basically the solution of part A of my question, where I have written the answer of it by using the tabular method. Similarly, in part B of my question, what do I have to find out? I have to find out the probability that x is greater or equal to 8 and less than or equal to 10. What we can do here again is that we can use this formula for x equal to 8, 9 and 10 and then add them together. Okay, this is one method. The other method is by using the tabular method, and in that method, what do I have to do? I have to use the x is less than or equal to 10, and from it I have to subtract the values for x which are less than or equal to 8. Okay, so I have to use this formula here. Now this and this, both of them can be found out by using the Poisson CDF table as well, which we have seen previously. The value of lambda will remain the same while the value of x will be 10 and 8. Okay, so let me move to the table. So this is 7.5 and we want to find out the value for 10. Okay, so the value for 10 is 0.8622. So it is 0.8622, which is for 10, and for 8 it is 0.6620. 0.6620. 0.6620. Okay, so this is the value for x is probability of x is less than or equal to 10, and this is for probability of x is less than or equal to 8. So subtracting this one from it, what we will get 0.3376. okay, so this is what we have here. This is 0.3376, and that is what we intend to find out here. Okay, so this we found out the value for this, and the answer we got from them is 0.3376. okay, so that is basically the solution for question 5.62 part B. Okay, so that's it for today, in which we have seen the solution of the question which is related to the Poisson distribution. If you have any question, you can ask me in the comment box. See you soon.